This is lesson 2.5, chapter 2, lesson 5. We're going to be using variables to solve equations. Just with addition and subtraction today. We'll do multiplication and division tomorrow. So let's just focus on addition and subtraction. You don't have to write any of this down, just pay attention. An inverse operation is an operation that undoes another operation. So for instance, if I have 3 plus 5 is 8, and I want to undo that, I would take that 8 and I would either subtract 5 to get 3 or subtract 3 to get 5. So in other words, subtraction undoes addition, and addition undoes subtraction. Therefore, they are called inverse operations. Multiplication and division are also inverse operations because we use multiplication to undo division, and we use division to undo multiplication. When two equations have the same solution, they are equal or equivalent. Okay, and I'm going to point more of this out when we start doing work together. Okay, next slide. The subtraction property of equality says that whatever you subtract from one side of an equation, you must subtract the other side to keep that equation equivalent, or to keep it equal. So, this looks like this. If I have 3 plus 1 on one side, that's 4. And I have 2 plus 2 on the other side, that's also 4. Well, if I subtract 3 from the left, I'm also going to have to subtract 3 from the right. And just remember from last year when I talk about the left and right, I'm talking about of this, the equal sign. This is what keeps it all in balance, right? This is what keeps everything in balance. I'm saying that everything over here is equal to everything over here, okay? So, using variables. If I add a to x to get b, then I'm saying again, let me just make sure we understand, this is my equals here, this is my equals here. So I'm saying that everything over here, x plus a, is equal to everything over here, b. So whatever I do to this side of the equation, I have to also do to this side. So here I have the x plus a again, and here I have my b. I'm subtracting a from this side, so then I also need to subtract a from this side of that equal sign. Okay? So, whatever you subtract from one side, you have to subtract from the other. How do I use that now to solve an equation? This you have to write. So I do want you to write that example 1 using subtraction to solve an equation. And I want you to tell me what it is we're solving. So you're going to write this and this. You're going to write solve and the problem. 214 equals y plus 112. I'm going to try using a different color, see if you can see it better. Okay. Let's see this one. Oop, that doesn't look very good, does it? Okay. Maybe blue? Yeah, blue looks good. Okay. So 214 equals y plus 112. First we write the original equation. So we've done that, write the equation. Then how do I solve this? Remember, your goal is always to isolate the variable. We're going to get this y all by itself on one side of the equal sign. Well, let me focus on this side and see what's with the y right now. So focusing on that, on just this side here, because that y is where I want to be looking. What do I have with the y? Looks like I'm adding 112. Well, I need that to go away. So I need to use an inverse of addition to make that 112 go away. What's the inverse of addition? You should have said subtraction. So how much do I subtract? Well, it depends. What number do I want to go away? I want that 112 to go away, then I have to subtract all 112. So if I subtract 12 from this side, though, over here, then I also need to subtract 12 from this side of the equal sign. I need to subtract 12 from both sides. And now I simplify. Okay? So subtract 112 from each side. So you should have this and this written. And now I simplify. 214 minus 112 is 102. 112 minus 112 is 0. Y plus 0 is just y by itself. So now I know what y equals. Y equals 102. To check, I want to make sure I check my answer. Oops. So to check my answer, I replace the y in the original equation with the number 102 because that's what I'm saying y equals. So where you have the y, I'm going to make this 102 instead because I said y equals 102. So 214 is 102 plus 112. Let's make sure I'm right. 2 and 2 is 4. 1 and 0 is 1. And 1 and 1 is 2. So yes, I am right. Next slide. Example 2, solving an equation with decimals. So you're going to write this down. And you're going to also write the original problem. Say? Okay. So writing the original equation, z plus 4 and 7/10 equals 10 and 3/10. So what do I have here? I'm going to focus my eyes on the side of the equal sign that has the variable. So I'm going to focus my eyes right here. There's the variable z. Now I ask myself, what am I doing with z over there? What's happening? What operation am I using? Am I using addition, subtraction, multiplication, or division? I'm using addition. Well, I need it to go away. I need z all alone, all by itself. Our goal is to isolate the variable. How do I do that? I have to use the opposite of addition, or the inverse of addition, which is subtraction. How much do I subtract? Well, let's find out. How much am I adding? I'm adding 4 and 7/10. Well, then how much do I have to subtract? 4 and 7/10 is correct. So I subtract 4 and 7/10 from one side, then I have to subtract 4 and 7/10 from the other side. So I am going to subtract 4 and 7/10 from both sides of this equation. When I subtract 4 and 7/10 over here, I get 0, which is exactly what I wanted. And when I do it over here, I get 5 and 6/10. So just in case you didn't remember, we borrowed from 10, made it 9, made this 13. 13 minus 7 is 6, and 9 minus 4 is 5, which is how I got the 5 and 6/10. Z plus 0 is z. Any number plus 0 is that number. So z plus 0 is z. So I have z by itself and 5 and 6/10. Now that I know that z is 5 and 6/10, I can replace z for the number 5 and 6/10 in my original equation. So in the original equation, 5 and 6/10 plus 4 and 7/10 does in fact equal 10 and 3/10. So it checks. Okay, make sure you get all this down as well, please. So you know exactly what you're doing. How is that the identity property of addition? Well, the identity property of addition says that anytime you add 0 to a number, the number doesn't change. It still has its same identity. So the identity of z is z. The identity of z plus 0 is still z. The identity of the number didn't change because you just added 0. Zeros don't change a number when you're adding. Okay, next slide. Addition property of equality. You don't have to write this down, just listen. Adding the same number to each side of an equation produces an equivalent equation. So same as addition. My original equation here is 3 minus 1 equals 6 minus 4. Well, 3 minus 1 is 2, and 6 minus 4 is also 2. So if I add 3 to the left, and I add 3 to the right, I'm going to get the same answer. 3 minus 1 is 2, plus 3 is 5. On the other side, 6 minus 4 is 2, plus 3 is also 5. So I still kept that equation equal by adding 3 to both sides. In variable terms, if x minus a is b, then x minus a plus a, which would be 0, so I have the x by itself, equals b plus a. You're going to get the same answer. Okay? Next slide. Now this you're going to write down. Example 3, using addition to solve an equation. Example 3, using addition to solve an equation. So we're going to solve this equation, x minus 31 equals 14. First we write the original equation. Now, what do I do with this equation? By the way, if you want to keep it horizontal, you can. If you want to write x minus 31, and then I want the x by itself, so I'm going to add 31 to this side, equals 14. Well, if I add 31 to the left, I have to add 31 to the right. So if it's easier for you to write it this way, horizontal, instead of vertical, that's fine. Okay? And just to make sure everybody understands what I mean, this is the vertical way of writing it, where you write the 31s under the left side of the equal sign and the right side of the equal sign. This is the horizontal way to writing it, where I write the 31s next to each of the sides of the equal sign. So, either way you're going to get the same answer. Minus 31 plus 31 is x by itself because this becomes 0. 14 plus 31 is 45. So now I know x equals 45. I replace x in the solution with 45. 45 minus 31 is indeed 14, so it does indeed check out. It doesn't matter which one of these you wrote, by the way, whether you wrote the vertical one or the horizontal one, but you just had to pick one, okay? So add 31 to each side, simplify, substitute, and check. Your guided practice. So, here, I want your eyes focused again on the side of the equation that has the variable, q, because that variable is what we want by itself. So what do I have to do here to get rid of that 16? I want that gone. Well, what am I doing? I'm subtracting it. What's the inverse of subtraction? Addition. How much do I add? Well, how much are you subtracting? You're subtracting 16? Then you add 16. So if I add 16 here, how much do I have to add over here on this side? If I add 16 to the left, I have to add 16 to the right. This becomes q. Minus 16 plus 16 is 0. So you can put 0. 9 plus 6 is 5, 15. 2, 3, and 4. So q equals 45. Check it. 45 minus 16 equals 29. Yes, it does. It checks, so we got it correct. Number 2. Again, you're going to focus on the side of the equal sign that has the variable r. What am I doing with r here? I'm adding. What's the inverse of addition? Subtraction. How much do I subtract? How much are you adding? You're adding 37, then you subtract 37. And whatever you subtract from this side, you must also subtract from this side. So, r plus 37 minus 37 is r, combining like terms. 65 minus 37 is 32. Make sure r is 32 plus 37 is 65. Yes, that's no. Hold on. Oh, my mistake, people. I'm so sorry. I did what you guys do all the time. That's kind of funny. 15 minus 7 is 8. 5 minus 3 is 2. Glad we did the check. I could see it's wrong because I know 7 plus 2 is 9, not 5. So that's how I knew that was wrong. Okay? So r equals 28. Let's try that now. 28 plus 37 is 65. 7 and 8 is 15. 3, 4, 5, 6. Yes, it is. So you should have gotten r equals 28. Next. Tell which property you would use to solve, then solve this. So first you're going to use the subtraction property of equality because we're subtracting from both sides. So on one side, on one side, I'm going to subtract now 24. On the other side, I'm also going to subtract 24. So on this side, x plus 24 minus 24 is x, combining like terms. 38 minus 24 is 14. Replace 14 where the x is to make sure you still get the same answer. 14 plus 24 is indeed 38, so I know my answer is correct, 14. So you use the subtraction property of equality, and x equals 14. Number 4, again, focusing on the side of the equal sign that has the variable. So we are going to use the inverse property of subtraction, which is addition. So the addition property of equality is what we're using. With the addition property of equality, we add how much? However much is being subtracted, 16 to both sides. So adding 16 to this side, I'll fix that. Should be equals. Okay? So y minus 16 plus 16 is just y when you combine like terms. 53 plus 16 is 69. Replace 69 in the equation. So 69 minus 16 should be 53, and it checks. It is 53. So you use the addition property, and you got 69. Number 5, we're almost done. Decimals, I like these because I need to make sure you all are remembering to line up that decimal when you're adding and subtracting. So I'm going to do this vertically, up and down, so that you can see that they're lined up. So again, focusing on the variable. So the variable z, and we're adding 3 and 2/10. So what do we need to do? The opposite of addition, or the inverse of addition, which is subtraction. And we're going to subtract the same amount, 3 and 2/10. Well, if I subtract 3 and 2/10 here, I also have to subtract 3 and 2/10 on the other side of the equal sign. 6 minus 2 is 4. 5 minus 3 is 2. 2 minus 2 is 0. 3 minus 3 is 0. So we have z by itself. Z equals 2 and 4/10. And again, you use the subtraction property of equality. When we substitute z for 2 and 4/10, and we add 3 and 2/10, we should get 5 and 6/10. And we do. So that one checks. Again, it's subtraction property, and z equals 2 and 4/10. Number 6, focusing again where the variable is, j. What are we doing with j? Well, we're adding 9 and 1/10. How do I know I'm adding? Not because of the addition sign. The addition sign tells me I'm adding j. That addition sign goes with j. How do I know I'm adding 9 and 1/10? Because 9 and 1/10 is positive, not negative. If it were negative, I would be subtracting 9 and 1/10. But since it's positive, I'm adding 9 and 1/10. The inverse property of addition is subtraction. So I'm going to subtract 9 and 1/10 from this side. 9 and 1/10 plus j minus 9 and 1/10 equals, the other side, 10 minus 9 and 1/10. This side, 9 and 1/10 plus j minus 9 and 1/10. When I combine like terms, I just get j by itself. The other side, 10 minus 9 and 1/10. I'm going to write this horizontally to make sure I don't make any subtraction errors when I'm subtracting decimals. 10 minus 9 and 1/10. You need to make sure we have that lined up correctly. Well, I don't have anything after the 10, so I'm going to add a decimal and a 0. Now I can borrow. Borrow from the 10, make it 9, and add 1 to the, to the 10's place to make that 10. 10 minus 1 is 9. 9 minus 9 is 0. J equals 0 and 9/10. When I replace it in with the j here, I have 9 and 1/10 plus 9/10 equals 10. Yes, that is correct. So you use the subtraction property, and j is 9 and 1/10. J is 0 and 9/10. Focusing where the variable is, I'm subtracting 18. What's the inverse operation of subtraction? Addition. How much do I add? 18. Well, if you add 18 to this side, I also have to add 18 to this side. So, m minus 18 plus 18 is just m. 4 plus 18 is 22. Check my answer. 22 minus 18 is 4. Yes, it is. So I use the addition property, and m equals 22. Last one. Focusing on the variable. What am I doing with the variable? I'm subtracting 11. What's the inverse of subtraction? Addition. How much do I add? 11. So I have n minus 11 plus 11. What do I have to do on the other side then? Take 37 and also add 11. N minus 11 plus 11 is n when I combine like terms. 37 plus 11 is 48. Let's check my answer. 48 minus 11 is 37. It checks. So I used the addition property and got an answer of n equals 48, or 48 equals n, and we're done. Sorry, this was a little bit more than 20 minutes. If you need to watch any part of it again, please rewind and review. You will have a quiz on this tomorrow morning. Thank you and have a great day.